Hello everybody. In today's video tutorials, I'd like to focus on 2D and 3D curves with Creo Parametric 4.0. Again, I will start directly from scratch and I will create new 3D model and I will set to specify the name. And I like to focus on the 40 different ways how to create curves directly in Creo. The first example is create from 2D sketch. So here is the base example how we can create a 2D curve. So we can select directly the sketch and select the sketch plane. And in the sketch, you can create standard line. Yeah, so you can specify the line or lines. Or you can specify the different shape, for example, spline, and you can continue and create the necessary shape. If you specify the spline, you can edit this information in the sketch. It means you can move the points, or you can specify the dimensions, so you can set the custom dimensions here. Or you can edit the spline. If you would like to work with spline, you can select double click and system will activate the ribbon for the spline. And over there, you can really easy move with points, or you can add the another one and select and specify better visualization of the spline. You can use the different kind of moving points. So for example, like this, and you can see here that the system allowed to you to specify the different kind of movement. Or you can run the analysis tool and you can work and specify the visualization of the tangency or curvature of the spline. So if you finish this feature, the system will create 2D curve directly in the Creo. On that curve, this curve you can use for the extrude feature, or for example sweep feature, or different kind of features. I think that you have seen a lot of my examples in previous tutorials, or stay in touch and I will show you how we can reuse these 2D or 3D curves with Creo Parametric modeling. The second example is we can create the curve between two datum points. So what we need to do, or what we need to create, is create the datum points. If you would like to work with datum points, you can create the datum points of existing curve. Yeah, and you can specify the offset. This offset is possible to specify by ratio or real. It means the system will automatically set a real offset dimension for you, and you have specified the first point. You can see right now, if I will switch on the visualization of the point, I can see the point here. If you would like to see the tag for the points, you can select view and specify this point tag display, and the system will always show you the naming of the points or datum features. I said that we can create a curve between 2 points. So if you would like to create this curve, you can see here that over there is the drop-down menu in the group datum, and we can create curve between 2 points. The first point I have created directly here, or I can select the point existing on the 2D curve. So you can see here the system will create points between created point or existing point. The created curve is possible to edit. What does it mean? If you select the definition again, you can specify the tangency of the point. So over here I can select the right mouse button and I can specify the tangency or curvature or normal specification. So for example, I will select the tangent and I will specify the connection. You can choose the tangent point if it will be this way or opposite way, and I can continue on the second side again here, and again you can change it. So you can really easy create your custom loop, and then you can trim the existing curve, and then you can use, for example, the boundary blend. So this was a second example how we can create the curve between 2 points. If you work with 3D, many times you create your custom, for example, extrude feature, and you will specify the shape here. And if I will create, so I will create directly here only, for example, 150. I'd like to focus and create only surfaces. Yeah, so you can see here right now I have created only surfaces. And again, I'd like to create a curve between points. So again, you can create a point on the line here and specify the dimension, or create it here, okay. And then really easy create the curve between 2 existing points. I'd like to finish this example, so you can see here that I can use the boundary blend feature and select 2 existing curves, and in the first direction it will be defined between 2 lines, and then I can specify the second possibility. You can see here that it's possible to create the trimming of that line, and you can specify that point, and the system will create correct datum or correct boundary blend surface for you. So it was a second example that we can create a curve between 2 datum points. The question is, if we would like to create a curve between more than 2 points. Okay, I will start almost from the scratch, and I will create more than 2 points. So I will create point here, or for example another one on the second curve, and then I would like to apply the curve directly on the surface. What we need to specify is offset dimension for that point. Yeah, this point is placed on the surface, and again I can continue, for example, on that curve. Okay, perfect. So right now we have a couple of points here, and what we can create is create datum curve through the points. So if you select more than 2 points, the system will allow to you to specify if you would like to go straight on, on between 2 points, or you would like to go as spline. So right now you can see here the system will create a spline for me between 2 points, or straight line. If you would like to go back, you can see here that is the possible select between point 1 and point 2, again the straight line. And you can specify another point, for example vertex. Here don't forget to select the control button, and then you can continue like here. So right now I have created the curve, place it on more than 2 points, and I have specified that I would like to create a straight line, not spline. What is good, between every point you can add fillet, so you can specify your custom fillet here, and again you can continue where you would like to create a fillet and specify the group. Yeah, the system will allow to you specify all together, or you can switch off and you can specify different radius here and different here. And then you can continue at fillet and specify the different radius here. For what is it good again? I have specified my boundaries or base shape. This base shape I can hide, and the system will create for me 3D curve based on the first extrude feature and datum points. And over here you know that is possible to use the sweep feature, for example, and specify the custom shape. Yeah, open shape or close. You can use the palette. For a really quick example, I will show you that it's possible to create something like this. For example, diameter will be 8, and if I will finish it, you can create the closed loop, or you can specify the thickness. Yeah, so again, it was a quick example how we can reuse the lot of points or couple of points and datum curve and sweep feature. At the end, the system created for you something like pipe. So if you don't have the application or licensing for piping, you can really quickly create a pipe like this. It's one example. If you will create the points on the coordinate system, yeah, so I will start again from the scratch. So I will delete this information from model tree, and I'd like to create a couple of points on the coordinate system. So I will switch on my coordinate systems. Yeah, this is the default. You can create your custom one, offset it from existing. It's the quickest way. So I will create my custom coordinate system. Yeah, you can specify the offset dimension and orientation, and then I like to create the points offsetted from the coordinate systems. You can see here that the system asks you from which coordinate system you would like to go, and you can really quickly and easily create new placement for the point, and it's necessary only select the new points here. Yeah, so you can specify the different placement, different position, and so on. So I will create a couple of points, 1, 2, 3, it doesn't matter. You can rename these points here, or you can import the existing one. How to work with this datum points offsetted by coordinate system, you can have a look on my YouTube channel, and you will learn more how to work with these datum points. Okay, so right now we have a couple of points in the 3D. I will switch off everything because I don't want to see the nodes and spin center. So, and right now I'd like to create a curve between these points. You can select right mouse button and the system allows to you to select all points, and you can see here that I can really easily and quickly create curve between points offsetted by coordinate systems. If you have a more than that one line, so I will go back and I will create the curve. Again, the sketched curve here. Yeah. And I will create a sketched curve here. I like to focus and show you how you can, I will use the Control D, yeah, because we have to define and see the default visualization. And right now I will switch off the datum plane or datum features. And the question is if you would like to connect these points. So you have seen that it's really easy because you can create a curve between two ends of the curve. So another example is that if you would like to create a curve between two curves, it's really easy. Select 2 points, and if you want, you can specify the in right mouse button if you would like to place in tangent, curvature, or normal. Yeah, finish, and opposite way, create another curve, place it here. Again, that curve you can right now use for boundary blend. So with Control button, select 2, second reference, and in the second side, I like to follow and create my boundary blend based on the curve 2D, 3D, and connected. For what is it good? For example, if you would like to specify this type of the shape, you can select and create the boundary blend feature, and then you can specify the thickness. So in this video tutorial, you will learn more, not only how to create the curves based on a different kind of features, but you will learn more, and you have seen, for example, sweep, boundary blend, and so on. I will see. I have prepared only the list what I would like to show you, so I hope so that you like my example and stay tuned. Okay, so it was example how to create the curve, place it on the two existing lines. The another example is if you would like to create and place curves and connect these curves between, for example, another surface. So this is the first surface what I have created, and I'd like to create, for example, a really easy shape here, and I will create only arc between two existing one. Yeah. And right now, if I will create extrude feature based only one straight line, or only one line or one entity, or not closed loop, the system automatically switch this extrude feature to surface modeling. So it's really cool. You can continue, specify the depth and finish. I said that I would like to show you how to connect the existing surfaces and existing curves. Yeah, so over here between 2 points and 2 surfaces, I like to create a correct shape. So you can create a curve between first point and another point. You can specify for example, the curvature, yeah, here, and opposite way, and the second side curvature here. If I will specify the curvature on left side and right side, okay, maybe better example will be if I will select edit definition, and on the right side it will be curvature, and on the left side will be tangent connection. I would like to show you more, maybe for example the surface modeling with Creo. If I would like to continue with another curve, I will select and specify the curve between 2 points, and again really quickly curvature over here, yeah, specified on the surface edge, and over here I will specify tangent on that edge but opposite way. So right now you can see here that system will create for me the curves which is connected directly to the surface and that edge, and opposite way it's the same. And what you can do with that type of the curve is, if you select the end conditions, you can see here that over there is the option, same as on the right mouse button, or if you select the option tab, over there is the possibility to tweak the curve. And if you would like to tweak this curve, you select the subscription, yes, subscribe it, and select, and over here is the movement, or you can add another points. And if you add the points here, for example, and then if you would like to move, select the movement and go back, and you can see here that right now you can specify the movement of the points here, and you specify the different shape. Yeah, so you can choose the custom movement. If I will confirm OK, so I have changed a little bit my shape of the curve. Yeah, you can see. And then I like to continue with boundary blend between 2 existing edges or lines. And if I will select the second, I would like to from left to right. Okay. And here is the option for the boundary blend. In the right mouse button, you remember that on the left side I specify the tangency for the curve. So over here I can select the tangents, and the system will automatically tangent existing surface and created surface. On the right side, I will select the curvature, and the system will create a curvature connection between these 2 surfaces. What does it mean? I like to show you on the analysis, and if I will select, you have the possibility reflection analysis. If you select more than 1 surface, it means 2 and 3 surfaces, you can see here that if the surfaces are tangent, between two surfaces, you can see here something like breaking. Yeah, so you can see here that it's not so smooth. Yeah, over here. But if you will specify the curvature, the transition between surface to surface defined by curvature, it's really smooth. Yeah, so you can see here that, whoa, I like it, it looks good. So it's the same like designers create the cars, and if you have a look on the cars, you can see that the connected surfaces are really smooth. So if you would like to repair this tangency, you have to go back in the model tree, you have to select specification and select the curvature on that curve, go back, and another one, select the curvature here, and then if the curve is curvated, the surface can be curvated too. So over here right now I can select the curvature, and in the analysis you can have a look here right now. It will be really smooth between two surfaces right now. The another example is how to project a curve. Many times you will specify and create a curve or something, and then you would like to make a projection on the existing surface. So for example, I will go back to the sketch and I like to create, for example, circle here. But what I need to do is make a projection of that sketch. So you can create a sketch and then you can select the function project, and the system asks you where you would like to place or project this sketch. So you can select the surface, and I would like to project it here. Or you would like to select the along direction, or you can specify normal to surface. So it depends what you can do. This is the first example. You can have a look that if you use this projection, the system will automatically hide the existing sketch. And again, why do you want to use it? Because you would like to create a hole here really quickly based on the surface modeling. You can select the surface and trim function, and you can select the projected the curve, and the system will show you what will be final result, and it looks good. Okay, again, I'd like to finish this shape here. So what we need to do is select these surfaces and merge it as one quilt. And if you will finish it, you can use the thickness, and the system will allow to you to specify the thickness. Yeah, you can go outside or inside or top and bottom. Specify thickness, and right now you know how to work really easily with surface modeling and some merge function, thickness, and so on. So I hope so that you like it and you are stay watching my video tutorial about the curve modeling or some example for surface modeling. If I will create another shape, I will start again almost from the scratch. So I will create extrude feature here, and in this over here I'd like to create the only surface. The specification will be only like this, for example. Okay, some dimensions, I don't care. Okay, I have finished my sketch of, I have finished my extrude feature here, yeah, in the model tree, you can see. And right now I'd like to create new datum plane, and this datum plane will be suitable for the new sketch. So you can directly select the sketch, but on the fly you can create a plane. So you can select and create a plane on the fly. You can specify the normal orientation for this datum feature, and I'd like to go on the outside of that cylinder. Yeah, and on that sketch I'd like to create, for example, rectangle. I think that will be a really good example how to make a wrapping of the curve on the existing surface. I'd like to explain to you what does it mean that if you will create right now the projection of that sketch, the system will automatically project it, but the length of the line will be not same like in the sketch. But I'd like to see here, if I will select the definition in my sketch, that my length of the line is 100 millimeters, for example that line, and if I will confirm, and if I will use the function wrap, yeah, so I like to wrap the sketch, this sketch, on that surface. So system will select for me my existing surface. If I will finish, you can see here right now that system will the system will wrap the curve on the surface, and the length of the projected curve is the same. Yeah, length the curve is, okay, I will select the control button. The total length curve is 100 millimeters. So you can see here the difference between projection and wrapping is that the wrap function let the length of the curve same as original sketch. So it was really quick example how we can wrap the curve on the surface. What next? If you work with your 3D data, many times you need to create the curve defined by equation. So the system, Creo Parametric 4.0, allows to you to create a point by equation. And you can have a look here. You need to specify the reference. So you need to specify the coordinate system, for example here. And you can choose what type of the equation will be defined by these coordinate systems, if it will be Cartesian, cylindrical, or spherical. And if you select, for example, Cartesian, you can see here that the system shows you the information window that if you would like to create a circle, you can write some equation. For example, the radius of the circle will be 4. So I will use the same function, and you can have a look here that it's possible to use the input from the keyboard, or directly you can choose the information here. It's a similar like relations. What does it mean t? It's a time from 0 to 1. So at the beginning, if the system will count this information, the system will define the information that at the beginning is time 0 and at the end is time 1. So if you imagine this parameter t is the time from 0 to 1. And I don't specify the z offset, so I will use the same, and it will be z0. You can combine your equation with local parameters. So if you specify the local parameters, you can create your custom one. And for example, radius will be 4, yeah? And it's mean I don't want to put here the number 4, but I'd like to use the parameter radius. Yeah, and same, I will put it here, and I think that you can use the right mouse button and function insert to relation. So I changed it a little bit, so you can see here that right now the system will create for me the curve defined by equation and specified by my local parameter. You can combine the local parameter and you can specify any type of the equation what you need. Okay. You need to specify and okay. So right now you can see that I have specified every information here. Yeah, change it to cosinus and sinus, finish, confirm OK, and finish OK, and you can see the system will create correct curve for you. And again, if you would like to change it, you can change the parameter, no problem. You don't need to go in the model tree and select edit definition and edit this parameter. You can go here directly to the parameters. You can select the feature and directly you can select the feature here. So feature has a parameter radius and I don't want to use the radius 4. I'd like to use the radius 150. So I will select OK and regenerate and analysis, for example. Yeah, so you would like to see the measurements. So diameter is 300 and everything was changed. Yeah. So the system will allow to me to change the parameters directly here. Yeah. So for the feature again, I will change it from 150 to, for example, 25. OK. And if I will regenerate and I will run the analysis one more time, you can see the diameter is again smaller. Okay. So right now you know how to create the curve defined by equations and how to use the analysis for created features. Right now, here is the questions if it is possible to create a 3D curve based on the 2D curves. Okay, for better explanation, I will create two 2D curves. So the first one will be here, and for example, it will be only straight line. Okay, and over here, I will create another one. So you can see here that we have this is the first line, and I'd like to create, for example, arc. And over here, I will specify the arc. So if I will have a look here from the top, the shape of it will be the arc, and the another one will be straight line. So what the system do? If you imagine that sometimes you need to create intersection between two curves, you can select the first curve, control second curve, and then in the ribbon you can select the function intersect, and the system will create for you 3D curve. Yeah, so you can see here right now I have my 3D curve. What does it mean? If I will change the original one from the straight line, I will add some lines there. So yes, they're a little bit complicated. For example, like this, and I will delete. And maybe, for example, I will create a fillet here. Yeah, change dimensions and confirm OK. The system will create for me the 3D line. Yeah, you can see here, it is a 3D line based on two curves. The first one and second one. From this side is the one shape and the another one. So it was example how to create the two 2D curves and intersect and create intersection. And another option is if you would like to create intersection not between two curves but between two quilts. So I will create the quilts defined by sketch 1. So I will extrude this over here. And again, I will select sketch 2 and extrude and make some like this. And the question is if it is possible to create intersection of the quilts. If I will select the function quilts here, so I will select the filter. I can select the first quilt and the second quilt. It is possible to choose the intersect, and the system will create for me the 3D curve based on the existing quilts. The final result will be same. So if I will hide the quilts, you can see the system created for me the 3D curve based on 2 quilts. Another example will be how to use and reuse the existing geometry. For example, if you create easy shape, for example rectangle, and I'd like to specify the depth, for example 150, and I'd like to reuse the existing line or existing edges, for example for the round or for another feature, or for example for the sweep. Yeah, so you know that is the possible. If I will change the filter back to the geometry, I don't want to see it again, you can select the edge, and if you use the function copy and paste, the system will create the copy of existing edge and create a curve for you. If you use the shift button, you can continue with selection and the system allows to you select the chain, or if you go to back with the shift button, you can select the one by one and select the different lines. Okay, so we have specified the existing lines, and if I will copy this one and finish it, the system will make a copy and create curve for me. Again, we can have a look here and we can select the curve for the sweep feature, and over here, for example, we would like to create that shape and confirm OK, and what we need to do is a cut. Yes, so it was really quick example how you can reuse existing edges and copy and paste and create 3D curve. The another example what I would like to show you is how to create the curve based on the sections. So I will create maybe more than one extrude feature here, and I'd like to specify, we can use this one and like this. Yeah, so for example, I'd like to cut, and I'd like to go, for example, for here. So I will select the shift button and system will select it. And right now what we need to create the correct shape inside. So we can create in the view tab, you can select the create a section, and you can select the surface and move inside. So system will create a dynamic section for you, and you can set the depth, for example 150. Yeah, okay. In the section, in the model tree, you can set the name. So if you will select right mouse button and rename, the system allows you to rename the feature here. And you can deactivate it. And you know that somewhere inside is created the sections. And in the model tab and datum group is the possibility to create a curve from cross section. And in drop down menu, you can have a look here. It's a cross section A, just created. And if I will confirm, the system create for me the, oops, give me a sec. I would like to hide this curve. And just created curve is this one. And again, you can reuse it for the sweep feature or boundary blend or surface modeling and so on. It's up to you. So it was a quick example how to create and use datum feature based on the cross section. And last but not least, here is the example how to create the curve from the mechanism. So for example, I have created really quickly and easily shape of the mechanism. I can move. Okay. So if it is possible to move with mechanism, you sometimes need to create a mechanism and set a maximum and minimum. I will transform and jump to application and mechanism, and you can see here that in my motor I have specified, if I selected the definition, that I don't want to go to the constant, but I'd like to go by cosine function. If I have a look here in the graph, you can see here my specification. What does it mean if I will specify not cosine by constant, and you will specify the velocity? The system will spin the model around and it will be goes left and right. But I don't want to go with this bar around. I'd like to only make some small movement. So again, in my analysis, you can have a look here. If I select the definition, that I have specified a snapshot and I have set some end time. So if I will run this analysis, the system will move with my mechanism a little bit. But question is, what was the maximum and minimum of this object? Okay, we can do it and we can analyze. What I have to do, I have to go back. I don't want to save it here because it's not so big. And I will select for example, this point or this object. And in this object, if I will open it, I'd like to specify the point here directly in the center of that cylinder. So we can create a point on the curve, but I don't want to place the point on that curve. I'd like to place it directly, no here, but here on the center. And the system will place it directly on the center of that selected curve. Again, if I will switch on, I can see my point. I will go back to mechanism and I will select mechanism. And what I need to do is run analysis one more time. Perfect, it looks good. And now you have in the mechanism tab, you have a group analysis, and over there is the possibility to create a trace curve. And what we need to do is select the point. So I will select the point and result. If I will confirm OK, the system will create for me 2D or 3D curve based on the mechanism analysis. If you would like to see it one more time, you can have a look here, and if I will play, I can set the speed and play, and you can see the system will create correct shape of the curve based on the mechanism. In today's video tutorials, you have seen a couple of examples how to create and use 2D and 3D curve with Creo Parametric 4.0. I try to show you 14 different ways how to work with curves. Thank you and bye-bye. Vladimir.